This module introduced you to tuples and how they are a first-class citizen in C#. The definition of a tuple is that it's a sequence of elements. You saw how to define this group of elements using a new syntax. You can give the different elements in the tuple names, which makes it easier to work with. When the compiler generates code for this tuple, it uses a generic value tuple, where each of the elements are stored in fields. It's worth to remember that these are not read-only. You saw the different ways that the tuple can be deconstructed and assigned. The most simple assignment is to store the tuple in a local variable, and then letting the compiler infer the type for you. You can also deconstruct the tuple into new local variables. This can be done in a few different ways. You may explicitly define the types that you deconstruct the tuple into, or you can reduce the amount of characters and make this a little bit more readable. If you want, when deconstructing the tuple, the values can be assigned to already existing local variables. There might be values that exist in the tuple which you don't care about. For those situations, you can use a discard to indicate that you don't want that stored in a local variable. You have to do this because the left and the right-hand side of that assignment need to have the same number of elements. You then learned that the tuples can be used as return types, or even as parameters to a method. Since we've seen what the compiler uses behind the scenes, it makes sense why this works. Use tuples as return types in situations where introducing a new class that represents the group feels unnecessary. To return a tuple from a method, you use what is known as a tuple literal. What is important here is the order of the elements. It doesn't matter what names you give them. If you do have a tuple return type, you should consider giving those elements names, as this will make it easier for whoever is calling this method to know exactly what each element in the tuple is. They can then use this to assign or deconstruct the tuple into variables. If you happen to swap the names when deconstructing the tuple, the value will end up in the variable at the specified position, but now it gets the wrong name. After learning about deconstructing a tuple into multiple local variables, we discussed that it would be beneficial to be able to do this for other types as well. If you create a void method on your class, interface, or struct that is called deconstruct with a number of out parameters, this will make it possible for an instance to be deconstructed into multiple different variables, according to the out parameters. You need at least 2 out parameters, and you can overload this method with a different number of parameters. It's important to know that you are required to have a different number of parameters for those overloads. It does not matter if only the types of the parameters are different. As a bonus, you saw that you can introduce an extension method that adds a deconstruct method to a class that you don't own. While we do own the order in our application, we'll just imagine that we don't. This means we could essentially deconstruct anything. We saw 2 really good use cases for deconstruction. One lets you deconstruct a key-value pair when iterating through a dictionary and map the key into a local variable with a better name, and the value into another local variable. This makes the code more readable and easier to understand. The second case was with pattern matching, where we used a tuple to define a pattern which we could use to compare with an instance. The instance was deconstructed to match with this pattern. This is exactly what we are going to explore in great detail in the next module. If we have a way of pulling the object apart and looking at its different pieces and traits in different manners, wouldn't that be a very good way of determining what an object is and what it isn't? We can do this in many different ways. One of them being what you got a sneak peek of in this module. Next, we are going to learn all about pattern matching and how to construct simple as well as complex patterns. This is definitely a language feature you will be using all the time.